Welcome to The Explainer. Today, we're going to talk about a huge project for any tech team, moving a database to the cloud. It's a journey that's absolutely filled with hidden traps, and we're going to walk through the essentials to make sure your first shot is a success. So, let's just kick things off with a big one, right? The question that keeps architects and SREs staring at the ceiling at 3 a.m. Because the single most common mistake teams make is, believe it or not, also the most avoidable one. Okay, so to really get this, we're going to follow the story of a development team. Their mission, move their big, monolithic application and its huge database into AWS. And their plan? Well, it seems simple enough. Just a classic lift and shift. They figured, hey, let's just take our database, plop it onto a virtual server, an EC2 instance, and call it a day. And on paper, it really does look like the fastest way to get from your data center to the cloud. A quick, easy win. But yeah, as you've probably guessed, that super simple plan, it ran headfirst into a really common and really painful problem. What looked like a smooth ride was about to get very, very bumpy. And here's the crazy part. For a little while, everything was fine. The application was up, users were happy, the migration was getting high fives all around, the team probably breathed a huge sigh of relief. But the cloud, it had a little surprise waiting for them. Now this visualizes the exact moment the party ended. Performance was great at first. It handled that post-launch peak traffic just fine. And then, about an hour to production, bam, it just falls off a cliff. The whole application grinds to a halt. So what happened? The culprit was something called the burst balance. Think of it like a hidden turbo boost, a temporary performance fuel tank for your storage volume. The problem was the team's database had a consistent heavy workload, and it just guzzled through that entire tank of extra performance credits. Once they were gone, performance got slammed down to a crawl. Their volume was just completely undersized for the real job. So this is the crucial lesson, right? This whole disaster forced the team to stop guessing and start actually architecting. A database doesn't run on good enough. It needs predictable, sustained performance. And that means you have to choose the right tool for the job. In the world of Amazon's Elastic Block Store, or EBS, this means you really have to know your options. Now, GP3 volumes are fantastic. They're the workhorse for most workloads. But for a mission-critical database like this one, you often need the heavy-duty stuff, the IO1 or IO2 volumes. With these, you aren't just hoping for performance, you are provisioning it. You tell it the exact number of IO operations per second, that's IOPS, you need, and you know that performance will always be there for you. And honestly, this number right here is why GP3 has become such a game changer for so many people. Every single GP3 volume you create, no matter how small, now starts with a baseline of 3,000 IO operations per second. That gives you a really strong, predictable performance floor right out of the box, and it helps a ton of workloads avoid that burst cliff we just saw. Okay, so solving the performance puzzle, that's only half the battle. The other half, and you could argue it's even more important, is architecting for resilience. You absolutely have to plan for failure. The team had this big aha moment. They realized that they couldn't just assume their backups would work, so they put this simple 4-step drill into regular practice. They'd take a snapshot, create a totally new volume from it, attach it to a temporary server, and, this is the key part, actually validate that the data was all there and correct. This turned their backup strategy from a theory into a proven, reliable practice. And this became the team's new mantra. I love this. It's a powerful reminder. You don't really have a recovery plan until you've tested it, timed it, and proven that it works under pressure. Until you do that, it's just a rumor. So with their performance problems solved and a recovery plan they could actually trust, the team got ready for their second launch. And this time, they created an essential pre-flight checklist so that absolutely nothing was left to chance. This is the exact kind of checklist you can hand over to your own DBAs and site reliability engineers. Have we matched the volume to the workload? Have we provisioned enough IOPS for our busiest time? Are we actually monitoring our burst balance, our backups scheduled? And the most important one, is our restore procedure tested and timed? It covers all the painful lessons we just talked about. So after applying all of these hard-won lessons, the team's second migration was a complete success. The application was stable, it was fast, and it was resilient. But their cloud journey, well, it was really just beginning. They did it. They hit their initial goal. They got their big, monolithic database running well in the cloud. But in solving all the problems of that first lift and shift, they learned a much more valuable lesson about what it really means to architect for the cloud, not just run on it. And that brings us to our final thought to chew on. It's great to get your database onto the cloud, but is it truly a cloud-native database? You see, a successful lift and shift is often just step one on a much longer and frankly more rewarding journey toward things like managed services, real scalability, and true cloud-native design. And that's something to think about.